so we have, this is kind of our repository. And so we open up IDLE, and we have this file here that's called test. And then I run the module. And so what it's doing right now, the machine is calculating all the different intersections.
Well, essentially what we're doing is basically, as part of the data model, we're basically generating a bit mask of basically all the edges that you would determine on the potential XY coordinates of the physical topographical lines, right? So as you can see, if you look at actually the hue lines. So it's the hue transformation. If you actually see it, it's actually constantly writing itself and doing more predictive analysis to determine what would be the XY data points for each joint. So over time, as you basically do more layering and more create this deep learning as part of the machine learning algorithm, we would actually determine essentially what the data points either from the XY, which would join into the Z, and over time it would essentially develop a self-learning model to create a potential CAD model or something that you might actually import into a Unity engine. So you could actually build essentially from a 2D model on an old school architecture, a 3D model that would be automatically generated from essentially an old diagram. Blueprint, I think that's what they call it in the architecture world. Blueprint. Yeah, thank you.
This is what, between the time that we were talking, it's going through and creating this kind of overlay.
And if you go back, there's also another file. If you look at the edges, 50150. So that is actually the edge detection for us to basically do the data analysis. Yep.
All right. Thanks.
So, just to be clear, how many of the kind of intelligences that you built in about kind of the architecture, how many of those were like manual heuristics that you were plugging in there, as far as the relationships of the lines, versus how many were like deep learning?
Well, the heuristic itself is actually the Hughes transformation. The Hughes transformation is simply just a computer extraction model that allows you to take essentially and plot the lines itself. So as you see, we're actually running a loop, then continuously actually running and comparing and XORing the actual the Glossenberg, which is basically the black and white inverted version. And then basically, if you keep on looking at how it is, if you go back to the original image, you actually see the red lines being generated real time. So what it is doing essentially is, as part of the learning model, you're basically graphing and analyzing how many times there's going to be an edge collision. Right? So as we develop more of these line collisions, we know that each of these, for example, there's some inconsistencies about how thick this is, but over time this will actually become a thinner line based on the amount of information that we do edge detections.
Yeah, so how do you deal, I mean, I think you answered a little bit, as more time goes by, it's sort of getting better and better. So is that a way that you would deal with some of the noise? I mean, I saw some of the examples that you gave, from hand-drawn to lines generated to then the CAD output. There was a lot of gaps and a lot of, it's taken a lot of noise because you have shaded areas in the hand-drawn and things like that. So can you also maybe, when it comes time to create a model, since you're dealing with existing conditions a lot of times, would you be able to mate that to like photogrammetry or something like that to try to clean up some of those conditions?
Yes, actually, that would be essentially the next step. Essentially, what you see from this, from the overall the top view of this, essentially, this is actually the bird's eye view of actually the actual, what it would be the base and foundation, right? So as the machine learning, as you continuously develop this neural analysis, you essentially determine that this is actually the Z vertical. So based on this idea, as it grows and understands essentially this model a lot better, it would actually start essentially analyzing this plot and growing it as kind of as a layering on top. So at the end of the day, based on kind of the spacing and actually based on radius and basically white space analysis, you could actually determine what would be actually the 3D model based on over time as this as the base and what this has at the top. So we're doing actually some deep, we're actually doing some actually deep search analysis, but we haven't got that far as over this weekend. I mean, our main challenge was essentially to really take the image extraction capabilities and determine what would be the baseline, at least for the 2D model. Right? But as we basically do more deep learning, we could actually then determine what would be essentially the 3D model as it continuously grows.
All of this weekend?
Yeah, pretty much.
All right. Thank you, Team 2D, 2 3D.